We're back with lightning talks, and the first talk will be by Shubhojit Mukherjee.
Hi everyone. Today we'll talk about observability of agentic AI. So agentic AI is a very okay. Let me introduce myself first. So I'm Shubhajit. I represent Reconsys, and I am an ardent football fan. So if I'm not watching football, I'm building something. So when we talk about agentic AI, right? So the observability part is something that's very muddy or muddled. So when microservices fails, right, they don't fail silently. They make a lot of noise and then they fail. You either know it's a 200 okay, or it's a 400 bad request, or a 404 page not found. But when agents fail, right, they just tend to decide differently. So you don't know whether it's actually a pass or fail depending on the 200 okay. So what we did to understand this part is divide the entire thing into three layers. One is a task layer. Here we understand are the tasks succeeding or not, whether you're getting a 200 okay or it's failing to start with. How many retries that are taking place? Say for example, you call the LLM, it fails there. So after how many retries do you stop? Or how many retries after that you go to a backup LLM or call another services? And what is the overall cost involved? So how many tokens are being involved per call? What is the prompt size that you're using? How to optimize that to see what are the n number of tokens that are being used for a particular call? Then comes the reasoning layer. This is where we see actually what the agent will do. So this is where we plan it. So we need to understand very specific prompt that are being used for one agent, or how that is performing, or exactly which prompt is being used for which agent. The third is we need to also know how the decisions are actually made. And then comes the final part, then the execution layer, where the tools are actually being invoked. So we need to understand then what is the particular MCP call that is being made, or which agents are being called, or how are they being invoked. So I don't have time to go through the entire case study. So on a very high level, we designed a financial system that had like lot of structured, unstructured data, and we had like lot of different agents for that. So we had a query restructuring agent, we had an agent to fetch the structured data from a particular thing, we had an agent to call the Python formulas based on a certain things that we are using. And so when we are going through all this, right, so we couldn't understand when things started to fail or where they are failing. Because the system was huge, we had prompts written for every use cases, but when the final output was coming, right, something was going wrong. And since the system is so huge, it's very difficult for us to pinpoint exactly what is going wrong and where it is going wrong. So that is where what we came up with, this is the concept of envelope. So what we are doing is we are taking certain metadatas in place, and also keeping privacy in mind, we are also hashing the prompts, so that when the engineers try to debug the code, right, so they would see something like this as the envelope. What it does is you have all your essential metadata to actually debug what is going wrong. At the same time, we have also taken privacy into account, and we are not showing the prompt as is, because it might also contain some PII information. So we are hashing the prompt and passing it to the end user, the engineers to debug. So once you have this level of debugging, right, what you can actually do is you can replay the events. So that becomes very essential when you're trying to replicate what is going wrong and trying to figure out how to fix and where to fix things. So this is where the replaying of event becomes very useful. And finally, what the end user sees is also a very structured thing, so that you understand, okay, this is what is working. So this is on the execution layer part. So once we design the system, right, what we actually get is from an opaque system to a very debuggable systems. And all the things that you have, right, it is very easy to govern what is going wrong and what is going right at any given point of time. You can restrict what is the data that you are sharing with the engineers and with the end users. And you can also have complete control of the envelopes that you are using. What we are trying to do here is we have multiple tools like Langsmith or Promptflow that give you like a granular level information. But when you're trying to debug an agentic system, right, it's very essential you take that one step back and look at it from afar, so that you can judge the entire system in its entirety. So that is where observability plays a major role in trying to figure out what is going wrong and how to fix it. And so these are most of the practices that we are currently using to get these things live in production and get a proper agentic AI solution in live. Thank you.
Thank you. Now we have Abhik.
Hi guys. So I'll talk of something really unique which no one talks about, and that is GPU. Well, that was a sarcasm. I think all the big tech companies are really chasing GPUs these days, and as many of you might know, GPU and CUDA and C++ is analogous, and people always associate GPU programming with C++. And as like Python programmer, I'm scared of C++. That's why we are all here. We are just too ashamed to admit it, right? So today we'll talk about Triton, the challenges in GPU coding, the compilation process, and some example code. I think, in my opinion, this is a very interesting realm wherein people are again sidelining C++ and going back to Python to develop cool stuff, right? So what do we want? We want something which is as simple as NumPy. Uh, that's what a revolution in normal scientific computing was, and as fast as CUDA, right? But this is a totally different hardware, right? CPU and GPU, they do a lot of compute, but that necessarily doesn't mean that the hardware is the same. When I say it's a very different hardware, let's check out the architecture. Uh, in CPU, you have very limited number of cores, less than 10 usually. In GPU, you have more than 10,000 cores, right? Uh, but this is a very substance level knowledge. The main difference comes in the memory and the memory hierarchy. Uh, each core in CPU has its own cache and control mechanism. As you can see over here in the diagram, uh, a bunch of GPUs have their cache and control mechanism. That makes us fundamentally different. What it means is, if we are, if we are launching something in GPU in a particular core, sometimes also uses thread, that memory is, shared. Why I'm talking about it, we'll get into the details of it in the next slides. But so what GPU guys majorly do is they don't think in terms of cores as CPU people. They think in terms of blocks, and all the control mechanism, all the load store that happens via blocks. Okay, not to lose you, let's now go slightly into interesting things. It was all just the background knowledge, and now we'll slowly understand why this background knowledge was important. I'll get back to the main point, why CUDA is complex. First, C++, I told you, right? And then there are other things, thread management, memory coalescing, race conditions. These are all the issues which a C++ developer faces when doing GPU programming. And the other thing is memory wall. How many of you know what is a memory wall? Okay, that's perfect. So I can educate everyone. So from 2000s till now, our CPUs and GPUs both have increased, like the computation speed has increased by a lot, maybe on the order of magnitude of say 1000. But memory, like the memory, the speed of memory access, that hasn't increased in the same rate. It has increased maybe 25. So what it creates is now the memory is actually slower than the computation. And that's very important point, because now, like, you can compute a lot more things, but you're limited by bandwidth, and all the NVIDIAs of the world, they are trying to, do a lot of innovation around it, and that's why they are doing so good and valued so high, right? So yeah, as I told, the solution is to think in terms of blocks, not in threads, because threads is a very, very low level control, and we don't want that. You have to control a lot of things. So what's the solution? So now, rather than writing in C++, you write in Triton, which is by OpenAI. So So this code is a simple GPU code which is like compiled uh, on the fly, right? Usually what happens is you compile the code earlier in C++, but thanks to Python, what we do is we compile this code just in time, and I'll just showcase this how GPU code is compiled. There is Python AST, we are aware, abstract syntax tree. Then on the fly, it creates a Triton IR, then GPU aware thing, and then LLVM, then assembly, and then at the end of the day, GPU code. I think that's it from mine. Thank you. Yeah, I'm around if you want to talk more about it. I do ML at Cloud Structure. Thank you.
Thank you. Now we have Jai Prakash.
Hi everyone, very good afternoon. So, how many of you here build a RAG so far? Majority of you people. Okay, fine. So let's say the uploaded PDF file that you have, all the relevant information, yet when you ask a query, your application failed to answer. How many of you face this issue? So any reasons why did it fail? Context. So right. So you lost some context for that particular query. That's where your LLM is unable to answer, right? But how do you address it? So there are many ways, right? So when you chunk the data, there are many methods that you can follow. One is character-based chunking, recursive-based chunking, and based on your file format also, you can perform a chunking. So based on that, when you retrieve the data, when you perform your semantic search, you can capture the most relevant information. But yet, so you will lose some more data. So what I'm trying to say here, I'm trying to talk about a research paper that is published, which is agentic chunking. So normally what happens is when you try to retrieve the relevant chunks, you let's say top 4 chunks, right? So the chunks are like this. Let's take for sentences, right? For every period there is a sentence, but you think that in the 5th sentence you might have the right answer. I mean, you might have the chunk that can help the LLM give the proper answer, but you don't have it. But with this proposition approach, so you're not going to store sentences, you're going to store propositions. That means whatever the input file that you have, you take the input file while creating chunks, pass it to LLM and create groups. And whatever the similar groups of text are there, from the text, you create the propositions for that. So this is how it looks. So in the previous approach, in the previous chunking strategy, you saw pieces of information, but here you see a complete proposition which covers almost all the information. So if you, with this approach, what you can do is, your chunks, when you extract like top 5 and all, you will have, you have fulfilled, I mean, the complete information will be there in each chunk. Each chunk will carry a full information, not that half-baked information. So with this, you can solve the problem. I mean, I don't say it's 100%, you'll get a better chance, but it's slightly better chance. It gives you slightly better chance at getting a better responses. And here are the resources which you can check it out. There is a chunk quiz demo, so you can see how splitters, different splitters work. And there is a retrieval tutorial which you can explore as well. So there the levels of chunking is being addressed, top 5. And this is being done by this research paper, the dense retrieval. And that's my talk. And we are hiring at Strive. Please scan this, and you can also visit at our booth. Thank you so much.
Thank you. Now we have Ayushman.
This one. Okay. Oh, it was not attached. Sorry. I thought it was attached because. Okay. Very good afternoon, everyone. I'm Ayushman Bilash Thakur, currently working as an assistant professor at Adamasi University. And today I'm going to talk about game development. Okay, so we have all heard this saying, all work and no play makes Jack a dull boy. So yeah, making games is fun. By the way, how many of you know this game being shown on the first slide? Yes, it is Silk Song. Yeah. So it has been a talk of the city at the moment. So this game is an indie game. So like a small company made it, and making games is about that, like a small team making that. And whenever I'm talking about games, I'm mostly talking about indie games. So what is a game? So I would say a game is an interactive media which conveys stories and experiences to users. Okay. And also, where can we play games? It can be anywhere. It can be PC, it can be console, it can be mobile, wherever you make your games for. So yeah, that's where we can play games. Next, why game development? So one of the things is money talks. So this is a clip from an article from Forbes where they are saying global gaming industry generated an estimate of 184.4 billion, where music and movies together could not cross that limit. So 26 plus 26, so it's like what? 55, 56. I'm not good at math sometimes. Okay. So, anyways, this is the monetary reason. Other than that, it's fun to share games with the people you are like sitting with and talking with. So, playing games together is always fun. And making games is a way to express yourself. So, this is a unique blend of like programming, art, music, everything. So, in terms of like other entertainment, I would say how drama is in general or theater is. Gaming is like that because it's a blend of a lot of media together. So let's just talk about a few essential concepts in game development. First of all, it's game design. So game design is basically how your game is working, what is the purpose of your game. For example, I hope every one of you have heard of Super Mario. So what is the game design of Super Mario? The Goombas walking from left to right, and your character Mario can jump, can move, and can stomp on Goombas. That's the game design of the game. Very, like, I said it very simply, but there is a lot more complications, but games generally come from this kind of a small idea. Okay, so this will be our game. Then there is the game loop. Obviously, this is another essential part of any games. Game loop basically is the loop where you like start the game, you play the game, and each second there is a loop going on. I will show you a quick demo later on, and where I will show game loop. And another thing is events. So like there can be, you can click on a screen, click on a button. Those kind of things are handled in games with event handling. So tools for game development. Okay, so game engines are one of the main tools you use for game development. So game engines basically provide you physics, rendering, and how to handle a few logic, and it does some heavy carrying for you. So Unity, Unreal, Godot. These are the like most popular game engines among the indie developers. So, and obviously Python has a piece of cake in it as well. Pygame, obviously one of the good open source libraries about games. And then there is also RenPy.
How many of you heard of RenPy? Pygame is very popular, but RenPy, yeah. So basically, RenPy is a tool for making visual novels. If you don't know that genre, that's more of a like story-based game. It doesn't have any like kind of important like gameplay content in terms of traditional sense. So Pygame, it's very easy to set up. Pip install Pygame in it, and there is a main game loop. And do we have time for demo? Okay, let's just try to do it very quick. So this is a game I made in like 2 minutes. It's just moving squares where I have this set up with the colors, the screen is set up, and we have movement and everything. We are running out of time, so real quick, this is my contact information. If you want to contact me, thank you. Okay, that's it. Thank you.
Thank you. Now we have Pragnya.
Hi everyone. For a quick survey, how many of your students, whether it's BTech, MTech, MSc, BSc, doesn't matter, how many of you are students right now? Okay. How many of you are interns working at any company or startup of your own? How many of you are interns? Okay, I think mostly it's founders and working professionals, academic researchers, so which is a great opportunities for the students to talk and learn from them. So I am a recent graduate, PS University 2025 batch, so you know how recent. Yeah, I recently graduated with BTech in Computer Science and Engineering, and I'm currently working as a software developer in IBM India Software Labs. So I want to talk about the challenges students face on a regular basis with respect to internships and obviously placements. So starting with internships, how many of you got a summer internship through campus? It can be a startup. It can be a senior startup or an alumni startup of your own college. How many of you got a summer internship through college? Okay, I don't see many hands. Maybe a few of them raised hands. Okay, how many of you got placement through your college? Through college placements? Well placed? Were you happy with that placement? Are you still working there? That would be awesome. Okay, so yeah, what challenges I'm talking about is the competition. Not just the market trend, the competition in your school, your college. So there's high competition, huge competition, and I think the boys will know what I'm talking about when I say diversity hiring, right? And the girls will also know what I'm talking about. Very few companies for very few roles, of course, they do diversity hiring. But yeah, not all girls who get a job is through diversity, okay? And even if it's because through diversity, it's not because of that. So what are the skills companies are looking for? I think you can talk to all the startups, people who have come here, all the researchers, all the companies, all the working professionals, managers, etc. So I think conferences are a great way to meet people, to connect with them if you're looking to change your job or if you're looking for internships. But starting with the challenges, obviously there's huge competition. If you go and search on LeetCode and HackerRank, you'll know what I'm talking about. If you're a competitive coder, then you'll definitely know what I'm talking about. You know how hard you've worked to get that LeetCode rank or HackerRank on the leaderboard, or whether it's through competitions, online events. So I think this is a great opportunity for students to hear, but also for companies, for startups, and for working professionals to understand why is it difficult. Because maybe if you finished college tens of 20 years ago, you would know that the placements statistics was not that high, but the fear of placements was also not high. But nowadays, everyone wants to do engineering. Everyone wants to go to IITs, NITs, and everyone wants to go to BITS, or if it's private universities, yeah. So how did I overcome the fear of placements? So one important advice that I got from my chairman or HOD, it was when you answer in an interview, even if you know the answer with 100% guarantee, don't answer immediately. Think for a few seconds and then frame the answer in your mind and then answer. She explained what works in the brain, what happens, which part of the brain gets activated, and then you answer, you will notice the difference. So I don't want to mention all the companies for which I gave the interviews, cleared the tests, reached the HR interview, and after the HR interview, maybe got rejected or didn't get shortlisted based on CGPA. So for how many people was CGPA a big problem or a big irritation during placement, or do you think CGPA never mattered for you? Anyone think CGPA doesn't matter at all? Okay, maybe. Did you have 9+ CGPA? No, okay. So if you're already a working professionals, then obviously you'll agree that CGPA doesn't matter. But for the students who are studying now, who have recently graduated, they'll know what I'm talking about because the competition is that high. And this year, current placement statistics is not good. So I would love to connect with startups and companies who are looking for interns. And there's a surprise reveal at the end. We are starting a community for internships and placements across Bangalore to connect companies and founders with students. So feel free to reach out to me if you're looking for interns. Thank you so much.
Thank you. Now we have Shweta.
Okay. We've been seeing a lot of different talks the last 2 days about agentic AI, Gen AI, and all of these AI-related topics. But I'm here to talk about something different. If you're in the cloud space, or if you're a DevOps sysadmin or an SRE engineer, I think you'll find my talk interesting. Hey everybody, I'm Shweta. I work at Canonical, which is the company behind Ubuntu. And at Canonical, we spend a lot of time thinking about how to make it easier to run applications reliably. And one of the biggest challenges that we see developers spend too much time on is wiring things together, like your databases, your proxies, observability stacks, applications, and keeping them running. That's the problem that we're trying to solve using Juju and Charms. Now, I'd like to introduce you to a few terms. The first one being Juju, which is an orchestration engine that allows you to easily deploy, integrate, and maintain Charms in the cloud. And you do this with the help of a special operator called as Charm. Juju and Charms provide a simple and repeatable way to maintain your applications across various clouds, including Kubernetes containers, Linux containers, virtual machines, bare metals, on both public and private cloud. Operations can become complex with sophisticated workloads on the cloud, and Juju tries to abstract all of this complexity by making operations on all the clouds feel the same. A charm is an operator, or in simple terms, it's a Python wrapper code that you write to tell your application what to do when it's deployed, integrated with other applications, scaled, and much more. You've got different types of charms, machine charms, Kubernetes charms, etc. The next one is Charm Hub. Charm Hub is an online marketplace and a community platform that's made by Canonical for discovering and sharing charms. So if you end up charming your own application, you can publish it on Charm Hub. Let me show you what it's actually like to deploy a chat application on Juju with a small demo. Yeah. So first you set up an isolated environment using multipass, and setting multipass is pretty easy. And then you after you deploy, let me pause it quickly. After you deploy multipass and you exec into it, you install Juju, you set up your own cloud, which can be AWS, GCP, whatever. And after that, you bootstrap your cloud on Juju. And you create a new model, and you deploy whatever application you want on that model. So over here, I'm trying to deploy Mattermost, which is a chat application. And after deploying Mattermost, I'm trying to integrate it with a PostgreSQL database by deploying the PostgreSQL charm. I'm also deploying self-signed certificates, which is another charm that will help you handle all the TLS-related events. In the end, I integrate all of these applications together, and then you have a production-grade setup ready and running. So I deploy, yeah. So meanwhile, while this is running, let me tell you a bit about why you as Python developers should care about Juju and charms. First is because charms themselves are written in Python with a framework known as ops. That means you don't need to dive into bash scripts, YAML, or any other heavy DevOps tooling. Instead, you can just express lifecycle hooks in Python, like what happens when your application is deployed, what happens if you connect it to a database, or what happens when you scale it. So, yep. Let me skip a bit of the demo. I'm skipping through all the part where we wait, and in the end, you can see that when I run Juju status, where you can see all of the applications are in a healthy and active idle state. Yeah, so now I have a fully functional database and chat application running on production environment. Here's this example Python code that you can see. All you need to do is inherit the charm-based class, and you've got a couple of events that you need to define, like what happens when you start the application and what happens when you install your application, and you define every event handler in the code. It's really that simple. And what can you do next? You can create your own charm application by following 12-factor principles, and you can share it with the community, or you can contribute to open source on Canonical. I've added a QR code with a bunch of links, including the tutorial and the GitHub repo, and as well as my LinkedIn. I'd love to hear about what you'd like to charm next. Thank you.
Thank you. Now we have Achintya.
Is it not coming? Oh, yes. Hello everyone. I am really sorry for the minimalistic design, but it was done for a purpose, and that is because I want to connect to you on a more fundamental level. Because my talk is on something which is very important to all humans present here and everywhere else in the world. It's on privacy. In the morning keynote also, we had heard talks about what AI privacy means and why it's important for you to keep your data secure, right? Now, I'm sure every one of you has heard about the US privacy-related issues that happened and Edward Snowden. Do these names ring a bell? Because what happened now is, oh, I think I'm flickering for some reason, yeah. Because what happened there was the United States of America, they were mass surveilling their people, right? They were collecting a lot of data about people, including their chat logs, their phone histories, and whatnot. So when such a thing happens, your privacy and your data is in the hands of people which you did not intend to be. Now, there's a field in cybersecurity called OSINT. If you've heard of OSINT, please raise your hands. Yeah, awesome. So OSINT is open source intelligence. It is about collecting information which is available online. It can be for any person. It can be tracing your LinkedIn post, your Instagram post, making inferences about where you were, what you were going to do, and what you might be doing, right? Now, who uses OSINT? OSINT is usually done by, say, insurance companies or government agencies if they want to track whether a certain individual is a threat to the country or not. Now, the scary part is it is almost possible to fully automate OSINT. Now, what is the problem with fully automating OSINT? Now, there already exist tools like Maltego or different ones which do some of the automation. But fully automating OSINT means that you are putting a tool which can literally extract information in the hands of people who don't know shit, and they don't know how it works, and they don't know how harmful can the data be. Now, who's doing this tool, right? It's actually been done by me. I'm Achintya Jay. I'm an undergraduate at IIT Madras, and it's really delightful to be here among you guys. So this tool that I'm trying to build it can take in images, it can take in videos, voice recordings, it can take in any sort of information, including binary files, and it can analyze it automatically, iteratively. It's we're using something called a depth-first search. So for example, if it figures out that, okay, the next best possible move for me to do is XYZ, so it's gonna dive into XYZ, then revert back to a state, dive into YZ, A, something like that. So it is a fully automated thing. It makes its own decisions, it makes its own ideas, and it executes them. So the question that I want to ask is privacy important to you? Because if such a tool exists, and if I can make it, then a lot of other people can make it, and you don't know who else has already made it, and where your data is right now. Because if you notice, if you log into Amazon and you search for some product, right, the next few Google ads will be for that product. You didn't intend it to be, but that's how it is. And if you, let's say, and it's very easy. It's extremely easy to do this. In fact, I want to show you the architecture that I was working on. Sorry for all this slides also. This is like version, oh damn, my bad. Wait, I have it locally as well. One sec. Not expected. I forgot to. Yeah, I'm calling this tool Atlas because it has a wealth of information. So like Atlas holds the sky, this tool is holding all your privacy apparently. Yep, it's currently at version 0.0.5. And it will be available when it's at version 0.1, which is a long way to go, like 95 more versions to go. But this is the architecture that I had in mind right now. It has three levels of hierarchy. It has something called the brain. The brain is what it decides that, okay, given all these information, the best thing that I can do is X, Y, Z. What happens next? Well, it goes to something called the upper agent, right? The upper agent has access to something called engines. These engines are everything I built. And right now, it's actually more than that right now. Like I was working on this right now, today as well. So these engines are higher level abstractions, which are essentially going to say, okay, if you want to do X, Y, Z, then the best thing for you to do is call this engine. And then you go further down there, you call different functions. And I have Rust bindings for you to run binwalk on your binaries. And similarly for browser automation, so it can actually open browsers and run different websites by itself. So yep, that was the idea. And I'll just finish. One sec. Yep. So the privacy concerns that I want to raise here is I want you all to think about what data you actually share online, and you should be very careful about what you're doing because such things are possible. And with that, I should take your leave. Thank you. Take your privacy seriously.
Thank you. Now we have Teja speaking.
Okay. Sorry about that. I won't take more of your time. I'll be really quick, I promise. I'm Kilari Teja. I work as a core engineer at Upson. Upson is a PaaS, platform as a service. We basically take people's code, build it, and deploy it on our servers with all sorts of security and think something like the one that the canonical speaker mentioned. Today I'm going to be speaking about backdoors, not the kind that the speaker before me was talking about, where you would use them to steal information, or like the NSA would try to tap into and get your phone calls or something. I'll be talking about backdoors. These would be utility backdoors. So sort of a way for you to interact with your long-running processes. For example, when you're writing a Python program, more often than not, it'll end up being a long-running process. What I mean by that is it'll be like an agent, a web server, or a background task, or an ETL pipeline. So something that will run for like an hour. And when that stuff is happening, you don't really have a lot of observability or like insight into what the process is doing, except for logs, right? Like you have a log of what it's doing, but if something were to go wrong, or if the state were to, if it were to get into a bad state, like there's not a lot you can do to change that other than stopping and restarting the process with the changes you need. And that's something you can sort of work around, and I'll show you a demo first, and then we can talk about it. So here I have a really simple Flask app. It has a single route on the slash endpoint. It returns a simple JSON payload with a single property called messages. And the way it gets it uses the global dict. It gets the greeting property, and it returns, which has a lambda or like a function, and calls the function, and returns whatever the function returns. So let's try running it. So I have the Python, the Flask web server running. Let's try to load it, and it says hello PyCon, as it should, because that's what it says here. Now, imagine if I wanted to change this string to something else, say something else. Usually what I do is I'd go change the code and kill the server, start it again. But here's another way of doing it, where this server this process also has a backdoor installed on it. I'll show you how that's installed really quick later. But it says it's installed on the 8101 port. Let's try to connect to it. I have it serving over a plain text thing, so 8101. And yeah, this is the backdoor into the process. Here I have access to all the global variables from here. For example, I'm querying the global state for the process that's running. So let's try updating the greeting to something else. I'll say yellow PyCon. And I'm not going to restart the process. It's still running with the same PID. You can check. And I'm going to restart it, and there you go. It changed to yellow PyCon. So I updated the value of a global variable without killing the process and restarting the process, and I patched it live. At Upson, we have a lot of microprocessors running all over the place because we have a big orchestrator, a lot of workloads. Sometimes things will go into a deadlock state, and you want to know what they're locked on. And you can do that quite easily. Just get into a backdoor of one of the agents, mess around with all the variables, try to get the stacks of all the greenlets or like all the threads running, mess around with them, check which lock it's waiting on. There you go. Yeah, the way I'll quickly show you how it's installed here. I'm using something called G-Event. You must notice that I'm not using fast API or anything like that, because this can be tricky to get working in a scenario where you have multiple processes, because each process has its own global state. So, this is running as a single process using G-Event as the concurrency engine. Look it up, it's really cool. And G-Event already ships something called a backdoor server. I've asked it to set up a backdoor at this ID, or like this port, with all the local variables and this banner, which is something that shows up when you connect to it. So yeah, we make use of this quite a bit at Upson, and it's really, don't install this on everything and try to mess around with the state all the time, because that won't end well, I can tell you from first-hand experience. But definitely try to use it, sensibly, and give access to it to sensible people. Thank you. And you can catch me outside. I have my username on most platforms is KSDME, so I guess find me or catch me outside.
All right, that was our last lightning talk. So a round of applause for all the wonderful lightning talks we had today. Everyone spoke really well. Yeah, that's all. Now we go for a break. Thank you.